In my last video on gravity from a macroscopic point of view, I defined gravity as the warping of space and time. But it's gravity on a microscopic level that makes things more interesting. And here's a quick disclaimer, before I dive into what gravity is on a subatomic scale, you might need some background knowledge of string theory. Anyway, there are two main types of strings, closed and open. An open string, just like the name suggests, is a string that does not close in a loop, but also an open string contains zero-dimensional particles at its endpoints called d-branes. A closed string, again just like its name suggests, is a string that's closed in a loop and does not have d-branes as its endpoints. Gravity is made up of subatomic particles which are closed strings called gravitons. Because gravity is a closed string, it can do something pretty interesting. You can think of our universe like a membrane, or a brain for short. And most of the stuff on this brain, like you and me, are made of open strings which are permanently attached to the brain via the d-branes on their endpoints. So in simpler terms, most of the stuff you see around you probably won't be able to escape the universe because it's permanently attached to it. However, gravitons, as mentioned earlier, are closed strings. This means gravitons can leave our brain because they're not attached to it. And this can mean something very important. As you can see, string theory allows for the possibility of multiverses or multiple universes. And every single one of these universes are brains just like ours. And as mentioned earlier, since gravitons are not attached to the brains, this means they can travel to other brains. Or in simpler terms, gravity can travel between universes. However, gravitons, just like photons, are massless particles and can travel at the speed of light. Unfortunately, the distances between universes are so large that despite the graviton's fast speed, it would take eons for gravitons to travel from one universe to another, which means we won't be detecting gravity from another universe for quite a while. In addition, how gravitons work is complicated but kind of interesting. To simplify it as much as possible, I'm just going to say that whenever matter and space interact with each other, they exchange gravitons, and this exchange of gravitons is what we perceive as gravity. But then this brings up another question, is gravity a wave or a particle? Well, an article at Fermilab answered this question. In the article, it clearly stated, and I quote, "Gravity is a force. For all other forces that we are aware of, we have identified particles that transmits forces at a quantum level. In quantum theory, each particle acts as both a particle and a wave. So if there is a graviton, we expect it to behave both as a particle and as a wave." This whole idea behind gravitons is one of the best things that quantum mechanics has to offer us, in my opinion, but there's just one small catch. It is all just a theory, so we don't know whether gravitons actually exist or whether they're a myth. However, mathematically, gravitons can exist. And so there you have it, the very basics of quantum gravity. Don't forget to like, share, and subscribe, and stay tuned for more science videos.